Okay, so an alternate approach to Bernoulli's. So if I had a Bernoulli equation, y prime plus p of xy is, what's the thing that makes it Bernoulli?
F of x, y to the r.
F of x and then y to some integer power. I didn't mention, and probably should have, that I hope it's obvious that y shouldn't be 0 or 1. Right? Because if, or sorry, r shouldn't be 0 or 1. Because if r is 0, this is not Bernoulli, this is linear. Right? Like this is easier than you're making it. If r is 1,
Then it's just. Then a lot of the 1 minus r is.
then you can divide by r and this is divide by y and this is separable. Right? So like don't beat yourself up over this if r is 0 or 1. It's only interesting if r isn't 0 or 1. So the book's approach, which is different and I'm now thinking maybe slicker than the one I usually use, is to guess y is the homogeneous solution or a homogeneous solution times some function u per the usual variation of parameters. Right? And then let's chase this out and see how it's going to work. So if y is this thing, what's y prime?
Product rule that.
Product rule that. YH prime u plus u prime YH. Right? Then if I cram this into the original, I get that y prime is that stuff, so I got it. I'm going to write this the other way. I'm going to write this as u prime YH plus YH prime u. Why did I do that?
It's going to be easier to cancel.
Because it's probably going to cancel with this next thing, right? So then I got a p of x, and then what was y? YH times u. And that's supposed to equal f of x. Okay, so that's YH to the r, u to the r. Everybody down with that? Now what? Why is variation of parameters a good idea?
Get y off the f of x?
No. Still there.
Well, yeah, because we haven't got rid of it.
Okay, yes, in the long run that's the idea. In the short term, why did I go find a homogeneous solution? I was hoping to see the homogeneous equation somewhere. So do you see y prime plus p of x y someplace in this junk?
You can factor it out of this.
Factor it out of
the second and third term.
second and third term, right? The usual spot. Like that's the usual spot for it to appear anyway. That guy's u times the homogeneous equation. Right? So in particular, since YH solves the homogeneous equation, what is that thing? 0. So if that zeroes out, you're left with u prime times your homogeneous thing is f of x times YH to the r and u to the r. So YH is a function you know at this point, right? You guys see that? So what am I solving for here?
U prime or u.
Yeah, I should be solving for u, right? So I want u prime by itself. Well, except there's u's. Thankfully, this thing is... What kind of differential equation is this guy right now?
Come on, Is it separable?
This is separable.
Are we gonna divide by u to the r?
We are going to have to divide by u to the r.
Where did that come from, looking back at that? I don't see where the u to the r came from.
That came from, I had a y to the r on this side. And y was yh times u. So I took yh times u quantity to the r, and I bumped that power on. So, this though, right, like this is a known function of x, that's a known function of x, that's a known function of x. So you got like y prime times a function of x is some other function of x times u to some power. You can rearrange that into u's on one side, x's on the other. So that's going to be u prime over u to the r is f of x yh to the r minus 1. There was going to be a 1 minus r and r minus 1 in here, right? Like that was going to happen. Okay, now what?
Integrate dx.
Yeah, multiply the dx over to, like, treat y prime like a fraction, right?
Oh, yeah, it's that.
So this is 1 over u to the r du dx is some junk I know. Multiply the dx to the other side and then integrate everything. There you go. The integral of 1 over u to the r du is the integral of f of x yh to the r minus 1 dx, which is probably nasty. Well, I think you know this one, at least.
So we know r isn't 0 or 1, so that's probably squared or more on the bottom. So it's
Well, it doesn't even matter. As long as it's not 1 and not 0, the integral of 1 over u is, 1 over u to the power is,
1 over r times natural log of 1 over u.
what if I wrote it like this? You're integrating stuff to powers, you go to the 1 higher power and divide by the 1 higher power, right?
Oh, yeah.
So I got u to the minus r plus 1 divided by minus r plus 1 is that crap. Oh, there totally would be a plus c over here. Okay, do I think you should memorize this whole rigmarole? Hell no. This is way harder with arbitrary, like with calling yh this whole time, right? It's going to be some function you know, because you're going to solve the homogeneous version of this, which is pretty easy. Then slap it in and know, the thing you want to know is that this substitution, like this is usual variation of parameters, right? That works on Bernoulli things, so it's not a waste of your time. But the way it works is a little bit different in that you get something that's separable here instead of something that's really, really easy. Like usually you just, after you do variation of parameters, you get u prime equals some function of x and you just integrate it. Right? Here you've got a little more complicated thing, but it's not that different. You guys follow that? So, know you're going to get to separable. Oh yeah, really I don't even care if you know what you're going to get, as long as you know that it's going to be separable. Cool?